Hi, my name is Terry Harrington and I would like to welcome you to Technically Speaking. Technically Speaking is a monthly program produced by St. Clair County RESA and features the programs offered at the St. Clair County Technical Education Center. We will show you what's offered at Tech and give you the chance to get an in-depth look at the variety of learning opportunities here. You will also see what students are doing, and you'll even have the opportunity to meet many Tech students, the staff, and even some alumni. In this edition of Technically Speaking, we're going to take a look at the Metal Machining Technology program. In this classroom, students learn to produce precision metal products from concept to finished product. And despite the tough economy, there are many jobs in this skill area currently available here in Michigan, and the U.S. Department of Labor is anticipating an up to 13% growth in these jobs over the next 5 years. Metal machining is a very highly technical area, and Tech students gain experience using high-tech equipment and processes, including Mastercam, CAD and CAM, computer-aided drafting or computer-aided machining, software and immersive engineering CNC software to complete the projects to perfection. Now that's a lot of technical jargon, so when we come back, I'll be joined by the metal machining instructor Dwayne Emick, who will help explain what all this means. Welcome back to Technically Speaking. We're out in the Metal Machining Technology Program workshop and talking with the instructor, Dwayne Emick. Dwayne, welcome to Technically Speaking.
Thank you, Terry. Appreciate it. Glad to have you here and the opportunity to be able to tell you a few things about our program.
So give us an overview of your Metal Machining Technologies program.
The metal machining program currently that exists here at St. Clair Tech is designed around a 2-year program. However, that's not to say that we can't take on a 1-year student, except for that student would only receive about half the program. The full enclosure of the program on a 2-year cycle is meant to give a student a strong foundational skills. We start them off with shop safety, of course, which is first and foremost. I want them leaving with all 10 digits that they walked in here with. And then we work in blueprint reading, we work in metrology, which is the science or the study of measurement. Because one thing that students find differently about this program is the accuracy and the precision in which we make our parts. It's unlike any others in the fact that close enough attitude doesn't work in our industry. It has to be exact. So we strive for perfection, and sometimes we miss the mark a little bit, but we still work on that and hone our skills. We then progress into some of the shop tools and equipment on the shop floor. We go into some handheld tools, drill presses, surface grinders. Then we get into the more elaborate machines, the CNC mills and the CNC lathes, and do some of the turning technology and the milling technology that we have here to offer our students. And that's all done through computer base. So not only will a student be able to work with their hands out in the shop, working on individual equipment, they'll also get the opportunity to work on some software through a computer and then go out and produce their parts that way.
So are you really preparing students for the engineering side or the manufacturing side, or is it a combination?
I would say it's a combination of both. I think to me ultimately the best engineer out there is a person who come up through the ranks of a manufacturer. To be able to understand if I design something for a certain reason or a certain way, this is why I'm doing it, and I can know the aspects of the machines as opposed to anybody can draw something on paper, but I may not be able to manufacture it just because I've drawn it that way on paper.
I know around these parts, you know, we really associate this with the auto industry, but are there a lot of other opportunities in addition to the auto industry that these students can go into?
That's one big fallacy I think that exists right now, is everybody thinks about manufacturing. And the first thing that pops up in their mind is the days of Henry Ford, the old 4 rubber tires. And I think we need to be looking outside of the box relative to the automobile, because there is so much more than in terms of manufacturing that these students have job opportunities and career opportunities waiting for them. We have the medical industry, as I stated earlier. That is huge. It's growing by leaps and bounds every time. We also have aerospace. Think of all the airplanes in the world that we're transporting and up and down. So there's a lot of need there, a lot of call. We also have alternative energies. Now, a lot of people don't associate alternative energies with manufacturing, but let's face it, Terry, everything has to be built and manufactured at some point in time. We also would have another great area in manufacturing would be the military or the government-based programs that are fighting our wars and currently supporting our troops overseas.
This is also traditionally one of those male-dominated programs. Are there opportunities for the female students too?
Yes, that's what I find very interesting is a lot of the females initially shy away because they say, oh, I don't want to get dirt under my fingernails. or they don't see themselves in a shop working. And there again, I think if exposure is the key. If we can have some of these young females come in, my classes do currently have a few ladies in them. I've had them in the past and they've been very successful. As a matter of fact, some of them have went well beyond some of the males that we've actually had in the programs when it comes to design and concept in this class.
Dorian, not only do students learn a lot of skills in this program, but they also have an opportunity to demonstrate their skills through SkillsUSA competition. Tell us about that.
SkillsUSA here is a student club organization that we offer all of our students. It's a student club organization that is meant to get more of an in-depth look at exactly why some of the students are here. Most of our students want to pursue this occupational area. They want to become more involved and more interested. And this is one avenue that allows a student to take a greater in-depth look if they're really interested in the occupational area.
You've really had some students that had a lot of success in this here too, haven't you?
Yes, I have. Over the past few years, I've really pushed the SkillsUSA only because I know the outcome. Reflecting back at my own experiences being a prior TEC student, I actually was a SkillsUSA student myself. Back then it was used to be called VICA, Vocational Industrial Clubs of America. They've since now changed the name. I went to the States. I took a bronze medal at the States. That's as far as I made it. I was very proud to do that. So to be able to come back here and teach what I'm now able to do and have share the same experiences for my kids, I get pretty excited about that because I know the ultimate goal, and that is the possibility of jobs and to further their education.
Now those kids doing the competition, they work on machines like we're standing in front of today, right?
Yeah, and that's why we chose what we did here today, Terry, is the machine behind me is a CNC machine. It stands for computer numerically controlled. It's some of the latest and greatest sophisticated equipment that these students are learning on in SkillsUSA. One of the areas in which that they'll be competing is they have to program, set up a machine apart in a machine just like this that you see here standing behind us, and they have 1 hour to do that. If that's not real world application, I'm not so sure what that is.
Great. What have students been able to do once they've gone through your course, once they've gone through the competition? Where have they landed?
Most of our kids, just only because living at home, they go out into the local St. Clair County community and find jobs. And some of them want to venture a little bit further. We've had some great success stories. Only from SkillsUSA has allowed them. At the state competition, for instance, they go on to nationals if they win states. And through the national competition out in Kansas City, Missouri, you'll actually see employers standing in line as these students win their gold, silver, and bronze medal, and they'll be handing them business cards. Please come work for me. Please see me after you graduate. Because these manufacturing business owners actually know that where would you go to find the best of the best? At a SkillsUSA competition. I've actually witnessed some of our students coming off the stage getting job opportunities. We had a young man a few years ago which graduated from Marysville High School who actually got a job working for the largest machine tool manufacturer in the world, and that's Haas Automation, which is located in Oxnard, California. He went out there and served an apprenticeship program. So to be able to go from graduating out of high school to California and getting a full-blown apprenticeship program is quite amazing.
What an opportunity for your students.
Yes.
Now, if a mom and dad came up to you and said, why should my son or daughter consider joining the Metal Machining Technologies program, what would you tell them?
That's one that I face every day, Terry. What I would comment to you on is I would tell those folks that currently right now, Michigan, especially in manufacturing, has what I call an artificial black eye. Because we are so greatly in depth with the automotive industry, being in our own personal backyards, a lot of the parents and a lot of the community is attached in one way, shape, or form with the automobile. I guess what I would like to comment on that or pass along as far as further information to those people is you need to think about what else is there besides the automobile industry. And also we're reaching at a time currently right now in manufacturing that a lot of the baby boomers, their generation is retiring. And we're not getting the amount of students to fill those positions and fill those jobs. Another thing that we've been greatly hit with, as you know, is the declining economy. How that's affected us is the fact that many corporations around us throughout the state, throughout the U.S. have closed their shop. Unfortunately, when that work returns, and at some point those shops are become busy again, there's going to be fewer shops to actually take on the workload, which means these jobs are going to be in high demand for our students here coming through St. Clair Tech.
When we come back, we'll have the opportunity to meet a couple of Dwayne students. They're going to show us how they make some of the parts and how these machines all work, so don't go away.
Take out meals for just $12.99. Call now.
Sherry Pearson? You are the sole surviving heir of the King of Montonopolis, and you are now worth $45 million.
I'm rich! This can't be real.
Of course it's not real. Come on. Having money isn't about luck. Like that takeout meal. Cook at home instead, you can save thousands a year. Feed me. Feed the pig.
So, Malcolm, you do know that energy savers last 6 times longer than ordinary light bulbs.
This isn't my room. It's Baron Davis's.
Baron Davis, the basketball player? This is his room?
Yep.
Interesting, because we have Baron Davis right here. Baron, do you live here?
No.
I don't mean that Baron Davis.
Millions of kids are using their energy wisely. What's your excuse?
Welcome back to Technically Speaking. We're talking to a couple of students in the metal machining program. We're talking with Rob Bohm and Dave Conkle. And Rob, what school are you from and what year are you in this year?
My home school is Grant and I'm a senior.
Great.
I'm David Conkle and I go to Port Huron Northern.
So guys, tell us a little bit about why you chose this program and what made you decide to come to Tech and specifically metal machining.
Well, I like to build a lot of things and I always make things homemade, you know, and I was like, there's got to be a better way to do it, and so I figured I'd kind of get into this class, see what it was about. Great. I really like it.
My family's been doing it for a while, so I figured I'd get into it, and I think it's interesting, because when I went to the open house, I thought it was really interesting too.
Very good. Has it met your expectations?
Definitely.
What has been the most difficult part of the program for you guys?
I think the most difficult part was just learning the basics of it.
What kind of skills do you have to be good at this type of program?
You got to be able to do like a little bit of math, have some common sense with things, and just learn to listen pretty good.
You got to be organized too and clean.
Okay, I can imagine, loking at the machines, and
yeah.
I could see where that would be important.
Because you're working with a little precision, you got to be clean about everything, you know.
Okay, and when you talk precision, I mean, we're talking what, thousandths of an inch or that type of thing?
Like your hair is like 3 thou, and we're going like 1 thou.
Okay.
Yeah, like a piece of paper is 2 thou.
So I mean, we're talking some real precise measurements and design, right? So describe for me what a typical week is like in class. What are some of the things that you do?
The kids have books. They have a CNC lathe that you could work on. You have mill and lathe books, manual machines, and they just work on those and do projects, and each project has like a different step and more difficult level to it.
Do you guys actually make a lot of different products here, or is it just kind of just practice, or?
We're given projects to do, and we got to process the job out, about writing down what you got to do and how you're going to do it.
Now just kind of walk a project through real quickly. I mean, do you have to design it paper, pencil? Do you do it on computer, and then translate all that to the machine, or?
First, we start with a design that we want to come up with. And, we draw it like this.
Okay.
And then we design it in design software. And then we got to write the code for it on the CNC machine.
So you're almost like a computer programmer.
Yeah.
Okay.
And we got to write the program, and we got to tell what the machine to do and how to do it and where to go. And
now I know Mr. Emick talked a little bit that not only do you guys get to do stuff in class, obviously, but you also participate in SkillsUSA.
Yeah.
How does that help you learn or maybe even improve on your skills that you're learning in class?
It puts you in a lot of challenging situations. You have like an hour to do a certain part of difficulty, and it puts you in a lot of real life situations, what an employer would look for.
Okay. Now, during the competitions, were there specific things you had to make?
Yeah.
We're given a blueprint.
Okay.
And you have to make that part to the blueprint within an hour with the tools that are given to you.
How challenging was that for you guys?
It's pretty challenging.
It's pretty challenging. It's really exciting too.
Well, it's got to be pretty gratifying. I mean, you guys got to states last year, was it? You went to the state finals?
Yeah.
So that shows you've got some skills, and that had to be a lot of fun and good experience.
It's really fun.
Yeah.
Now today we're going to be making a product. You're going to show us what to do. Tell me what we're going to be making today.
Okay, well today we're going to be making a spark plug.
Okay.
For the open, or they're going to be doing an auto show, and so we figured for all the contestants that enter, we'll give them a nice little prize. So.
Yeah. First we started off with this hand drawing. You know, we got a spark plug, and we just drew up the dimensions and how we want it, and all the details how we wanted to do it. And then we drew it up in CAD CAM software, and we got a drawing here.
Okay.
And then we made a plastic wax model, rapid modeling, and it's called stereography.
Okay.
And we make this to see if it's going to work before we go through all the hours and hard work.
And you need to make a model for every part you make.
Yeah.
To make sure it's the right dimensions.
You don't waste money if it's wrong.
Okay, good.
And then we took all the math dimensions from all that and wrote a program for the CNC machine and made a spark plug.
Can you describe for us real quick what a CNC machine is?
CNC machine is computer numerical control, and basically you have a bunch of G codes and M codes which tell the machine what to do, and you have X and Y coordinates, and you just punch them in and it'll do it for you.
Okay, so we had the idea, we've got the drawings, you made a prototype, all ready to go. So you ready to go make a part?
Yeah.
All right, let's go back to the CNC machine and see what we can do. So Dave, here we are over at the CNC machine, so tell me what the first step is that we need to do.
Well, this is the CNC Simulator box, and we need to take our code that we have written for this spark plug model we're making, and we got to put it into the simulator to see if it's going to work or alarm out. So we put our code in here, we write all this and we type it in, and then when we're done putting the code in, we test it out to see if it's going to run, and then if it alarms out, we have to figure out the issue, because if one thing goes wrong, you can crash the machine, you know, bad tooling, you could ruin tooling and waste time and money.
Now, how long would it typically take for you to put that code in?
It really depends on the size of the part or the details in it. Like right here, it wasn't too bad. It didn't take that long. Probably 10 minutes to type it all in there.
Okay. And the code basically tells the CNC machine every step that it has to take, right down to the thousandth of an inch, right?
Yeah, what to do and how to do it. Like this code right here, G01. It's a linear move. And I'm telling it to go Z negative a quarter inch in Z. And like this G03, I'm telling it to go X an inch, you know, Z negative 801 thousandths.
Now, in the typical machine shop, would they have a simulator like we're using today?
Typically. I mean, they have a graphics simulator on their machine too.
And the purpose is, again?
To save time and money and tooling.
All right, good. Let's go over here to Rob. He's over at the other part of the machine and getting ready to put the stock in and get us all set up. So Rob, tell us what you're doing.
Okay, so basically we're taking a 1-inch raw piece of round stock and we're going to turn it into our part that we made all the coordinates for.
All right, show us what you're doing. Now, how long will it take to make the part with the code that we're put in here?
It has a cycle time right there, so.
Okay, about 3 minutes, 39 seconds, so.
Yeah, and right here you can see it's going through all of the G codes and M codes and functions on the machine, and it's following all those coordinates with the cutter right now.
Okay, so the programming is really the key to this whole process, isn't it?
Yeah, it's the heart of it.
Okay. Now, what about for like maintenance on the machine? Is there a lot of maintenance you have to do to make sure you keep that precision and everything right there?
Not really, just keeping cutters sharp and everything. Make sure you don't have broken tooling.
Okay.
It's taking that stock and it's making it all blanked out, and it's going to get it to a rough dimension, and then it's going to go back in and finish it all.
Okay.
And make everything look like
and
it's
of
supposed
course,
to.
because we're cutting metal, there's a lot of cooling that has to take place, and
you
that's
gotta
what we're
keep
seeing
everything
on the
cool.
window, right? Okay.
Yeah.
Very good. So once we get through all of these steps here, and you can just see it's just rolling up, 5 or 6 steps at a time here real quickly.
Yeah.
Then where does the part come out?
The part should come right out here.
Okay, so I guess
Parts
we need to
catch
sit
on
and wait.
All right, now our program's finished, and here would be the part. It's almost finished, and now I gotta go head over to the mill.
Okay, and Dave's waiting for us
Yep.
over there. Let's go see Dave. Here we are back with Dave for the final process for making this spark plug. So Dave, tell us what you're doing and why.
Well, we're going to bring it over to the indexing head so we can mill our 6-sided hexagonal flats on there. Because we didn't have hexagonal stock to do the part, we have round.
Okay. Is this normal process for most parts that you have to do a final project, finishing project with this?
Yeah. I mean, if we don't have right we don't have hex, or we need a flat on something, we just need one flat, we bring it over here to the indexing head.
Okay, tell us what you're doing.
Well, I'm going to cut these flats right here. I'm going to turn this 6 2/3.
So again, it's another precision measurement that you have to be able to do on this.
Yeah.
Now in a typical machine shop, would this be done by hand or would it be automated pretty much?
It would be done by hand because, I mean, unless the shop does a lot of things with the indexing head, they have them for the CNC machine too.
Okay.
Well, now that we're done, take this out. There you go, finished product. Spark up yourself a future at St. Clair Tech.
So, April.
Yeah?
You know your charger's still using energy when it's plugged into the wall, right?
Yeah, but that's not my charger. I don't even have a cell phone.
Millions of kids are using their energy wisely. What's your excuse?
In the event of a car crash, 3 out of 4 kids are not as secure as they should be because their car seats are not used correctly. But the latch system makes it easier to get it right and to hold your kids tight. Anchor, tether, latch. Learn more at safercar.gov.
Well, that's going to wrap up this edition of Technically Speaking. Thank you to our instructor, Dwayne Emick, and his students. We hope you've enjoyed learning more about the metal machining program. And don't forget to check out our website at sctech.org. We invite you to join us on the next edition of Technically Speaking, celebrating 35 years of St. Clair Tech, when we learn about Tech's cosmetology program. So thanks for joining us. We hope to see you the next time we are Technically Speaking.